Okay, so this is a section in 4.2 where we look about all these different identities and we're going to use them coupled with a unit circle. These identities are meant to help you with the memorization of the chart. So the even-odd identities, my even functions are cosine and secant, and the even identities say that I have cosine of a negative angle. That is the same thing as saying cosine of a positive angle. So if this is true for cosine, this is also true for secant. So if I have a secant of a negative angle, it's the same thing as saying secant of a positive angle. My odd identities are the remaining four. So sine of a negative angle is the same thing as saying sine of a positive, it's the same thing as saying the negative comes out front and then it's sine of a positive angle. This is also true for tangent. So tangent of negative theta is the same thing as saying negative tan theta. Cosecant of a negative theta is the same thing as negative cosecant theta. And lastly, cotangent of a negative theta is the same thing as saying negative cotangent theta. So I'm going to show you how to use these even-odd identities. Notice the focus is on we use these when we have negative angles. So for our first example, we have sine of pi over 6. So sine is an odd identity, and the identity says if I have a negative angle, which I do, the negative comes out front, and now we're evaluating sine of a pi over 6. And from the unit circle, we would identify that pi over 6 matches up with the coordinate square root of 3 over 2 and a half. And since we're dealing with sine, remember that sine is y over r. So the negative is going to come down in front, and now we need to figure out what sine of pi over 6 is. So I'm using the coordinate because it says pi over 6, and I'm going to pull out the y part of the coordinate. And the y part is a half. Remember, the radius from the unit circle is always 1. Anything divided by 1 is itself, so the answer is negative 1/2. So sine of negative pi over 6 is a negative half, and that's our final answer. So let's try one more. So here we have secant of a negative pi over 4. And secant is an even function, so the rule says that if there's a negative angle, the negative completely gets dropped. So this is the same thing as saying secant of a positive pi over 4. And we'll go off to the side. From the unit circle, pi over 4 is root 2 over 2, root 2 over 2. And secant is r over x. So secant, using this coordinate r over x, so my radius is 1 over my x value of root 2 over 2. And to fix this up, multiply by the reciprocal, so we get 2 over root 2. Now we have to rationalize, so I get 2 root 2 over 2, 2's cancel out, and we get the square root of 2. So the final answer is the square root of 2. So the even and odd identities, again, focus more on negative angles. That's where we use those identities. So now we're going to go over 3 more sets of identities. So the reciprocal identities, reciprocal meaning like the opposite, says that sine of theta is the reciprocal of 1 over cosecant of theta. That's why we kind of set them up the way we do. They are opposite. Cosine of theta is the reciprocal of secant theta, and tangent theta is the reciprocal of cotangent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And lastly, cotangent is the reciprocal of tangent of theta. So essentially all the rules say that if I know sine, I flip sine and now I know cosecant. If I know cosine, I flip it, I know secant, and etc. Next set of identities are my quotient identities, and quotient means division. So tangent of theta is equal to sine of theta over cosine of theta. And I want to just kind of prove this to you so you understand why this is true. So sine is y over r, and cosine is x over r. And if I needed to, fix this up, I would multiply by the reciprocal, so y over r times an r over x. Notice I have an r up top and bottom, so they cancel, and I'm left with y over x. And tangent is equal to y over x. So that is why tangent is the same thing as saying sine over cosine. So similarly, this rule applies to cotangent. Because these are the reciprocal of one another, cotangent is the same thing as saying cosine over sine. So that's the next set of identities. And the final set of identities is the Pythagorean identities. And there's 3 Pythagorean identities. First one is sine squared of theta plus cosine squared of theta equals 1. Then we have 1 plus tangent squared of theta equals secant squared of theta. And lastly, 1 plus cotangent squared of theta equals cosecant squared. Now, of these 3, the most popular one that we'll use is the first one. You'll use that one the most frequent out of these 3. So I would like to show you an example as to how all of these identities come together. So the problem says if sine of theta equals root 3 over 2, find the remaining trig function. So notice I'm only giving you one trig function, and I expect you to obtain the other 5 trig functions. So right off the bat, we have sine of theta. I'm just going to set up my chart. And I'm going to do the work on another screen, but I'm going to constantly be flipping back to the screen to fill in our final answers. And I suggest you kind of do the same. Write out your 6 trig functions at the top, and then you'll do all your work below this for obtaining the answers. So I gave you root 3 over 2. So using the reciprocal identities, if I know sine is root 3 over 2, that means I know cosecant must be 2 over root 3. And we have to rationalize, so we multiply by root 3 over root 3. So the final answer for cosecant becomes 2 root 3 over 3. But as far as this goes, I use the reciprocal identities. Now I've kind of hit a wall. I can't figure out the rest of the 4 trig functions. So this is where we're going to use the Pythagorean identities. So I'm going to switch the screen, and we'll constantly be coming back to this one. Since I gave you sine, that means we're going to start with the Pythagorean identity that says sine squared plus cosine squared equals 1. So sine is the square root of 3 over 2, but the quantity is squared. And whenever you are squaring something, I suggest you write it twice because it visually makes it easier to look at. So we're going to multiply these together. So the square root of 3 times the square root of 3 is the square root of 9, which puts me back to 3. 2 times 2 is 4. And I'm going to write this 1. We could think of 1 over 1, and if I wanted common denominators, we would change it to be 4 over 4. We're going to subtract 3 over 4 from both sides. I'll come over here so I have more room. So cosine squared of theta equals 1 over 4. We take the square root. So cosine of theta equals, the square root of 1 is 1, and the square root of 4 is 2. So by doing all this, I have now determined that cosine is 1/2. So I'm going to go back a screen to fill this in. So we know cosine is 1/2. And since I know cosine is 1/2, that means the reciprocal, my secant value, will be 2 over 1, which is 2. So the last thing we need to do is determine tangent. So tangent, we're going to use the quotient identities, and tangent is sine over cosine. So my tangent value is sine over my cosine. So for my sine value, we got the square root of 3 over 2, and for cosine, we got 1/2. So we will multiply by the reciprocal, Notice the 2's are going to cancel, and we get the square root of 3. So going back to the screen, we found that tangent is the square root of 3. You could think of this as like a square root of 3 over 1. So cotangent, when I take the reciprocal of that, I get 1 over the square root of 3. We have to rationalize. So cotangent is root 3 over 3. So notice using those identities, if you know one value, you can determine the remaining 5. So that is all for today.